Hello and welcome to week 2. In this week we will be going over chapter 3, which is functions. The first section we're going to go over is floating points. Now, as you have read or should have read that with a floating point or with the data types for floating points are actually float and double, which float is not used as much, so we'll be using double. And in regular class, we use double as well, and within the book. So, with that being said, um, you'll notice that we have two different parts on a floating point, which is our integer part, which is before the decimal, and you'll have the floating part, which point, which is after the decimal place. So, the first short program we have is double pi. And what this is doing is showing you two ways that you can assign a number or a value to a variable, which we have here. The one way is actually declaring our variable, which we have a double, which we know we have a something point something, and then we have pi, which is this is our assignment right here, which is pi equals 3.14159. Now another way of doing it is actually assigning everything on one line, which you can do. Sometimes it's easier to do it this way. Sometimes we'll have to change the value of the variable. So right here we have x equals 1. So let's just get this so we can have an output and we can see how that we can see that these are actually saved to these different variables. And I'm actually going out my way a little bit and putting this inline in the middle right here instead of on the end. It's just a sometimes I like to do it the long way to show you how to do the information. So we press F9 to save it, and we're going to just save it as floating underscore point dot cpp, and we press save. Alright, we saved it. Now we're going to press F11 to compile and run it. So we see what we have here is we have it saved one way, 3.14159, and then we have x was equal to 1. Now let's go on to the next little section. It starts talking about, and what we're going to do, I'm just going to delete this so we can have a little clean little space. Now it's talking about, or it explains to you how typecasting is. I'm not sure if it actually mentions typecasting. And then looking, I'll have the book over to the side. It looks like it doesn't talk about it, but please look up that type, TYPE casting. And what that is just actually the computer automatically turning a double into an integer or integer into a double. So we have, they explain two different values right here. 1 divided by 3, and the first one actually don't need. It's just showing you that we're have it right here. So let's take this one out and let's see what this is going to do. So we're going to see out y. Now you'll think that it would be, our answer would be a something point something number. However, it will not. And let's save this. And let's see our output. And as we see, our output is actually 0. So instead of 0.0 is 0 because it looks at these as two integers and displays it as a integer. Now, in most cases, it usually come out as 0.0 only because it saves it as an integer and then turns that into double. But in this case, it actually saves it and enters as a double. So let's see 1.0 divided by 3.0, and let's see out y. Now, if you notice, there's some things that's going on that you might not have seen before, that I have two of the same variables. Variables can change, and in this case our y will be changing from this number, from whatever this output, to this one, and it'll run this first and then it'll run this. So let's see. Actually, in this case it will not let us do it again. However, let's do an easy fix right here. We'll say put a 1 right here, we'll get output, and we'll say 2 right here, which gives output. You cannot, we could have it as the same variable if I did not put this double right here, but we want to go ahead and do that just for this section. So and what we did not do, cout, let's put a inline right there so we can separate the two. Remember, every time that you open it, you have to close it before you can save it and run it again, or compile and run it. Now we have 0 for the first one, we have an inline which returns to the next one, and then we have 0.33333. So we have this section, and I will go into the next section in a few. Now let's look at chapter 3, section 3.3, which is the math functions. So functions. So we start our programming is number sign include IOString using namespace std int main. Then we have our open and closing, and we have return 0. So this right here is our shell. So in the math functions, these are predefined functions, and what that means is that the compiler, when they see them, they will see these keywords and know what to do with these keywords. However, with using these, we will introduce a new header, and along with our IOStream header, we have a new header called the CMath, which we will write as numbers I include, and we'll have CMath. Now, with this, there's a list of different functions, as including the header files and the methods or the functions that you use, such as the log, sine, cosine, tangent, square root, and things of this nature, is in a article that I've uploaded, and it's on the handouts of my Talladega. So just to briefly show you, we'll pull it up. It's in, let's see, this is week 2, well, logged out, and it is in this section here up front. Also having other informations, the formatting output, but right now we're talking about the math functions. You can use these for examples, and also to do your homework. Now, to just give an expression or give examples of these, for instance, we have maybe, let's say, we have an angle of 1.5, and this is in radians, and we will have the height, which is the sine angle. So we have to use double height equals the sine of angle. Now, what we'll do is see out height, and we will get our output. So let's actually run it. Save and run this. Excuse me. We'll call this math underscore functions dot cpp. We'll save that. Let's see, and the answer that we will get is 0.997495. Okay, so let's see, can we do some that we actually know the answers to. So we would say, for instance, we want to use the square root. It's so what we'll do, or no, not square root, we will do the square. So let's take a look at our document here, and let's see, do they give an example? No, inside here they don't. However, we do have some of the extra books, and you can go online to look at many different ones. However, the book that I usually use for the course for the fall and spring is called Programming and Problem Solving with C++. Right now we're in the 6th edition. You can also use the 5th. The author is Neil Dale and Chip Weems. Nelldale, Neil Dale, and Chip Chip Weems, Weems. You can try to find that online. Not sure if it's offered online as an older version or what. Alright. In the book, the book that I have, it actually gives you the square root, so we can find the square root, no problem. So the square root does use the CMath. So let's see, can we find the square root? Let's just get an output, which is the square root of a given number. Let's say 9. And I bypassed all that because if I'm not mistaken, it's gonna ask us to put it as a double, or not. Let's see, it did not give us. Let's try to take this out. Like I said, these are live streams, and with the mistakes that we have, we're going to have all the mistakes completed. Alright, so we know the square root of 9 is 3, and that's the answer that we get. I think what I did was I compiled it and ran it, and instead of saving it, it compiled and ran the old version and just um, prompt up what we had there. So that's no problem. So we have the square root. Another example would be the cosine. The absolute value. This is just like we do regularly with absolute value. We can just say cout and This time we're going to put a value. We're going to say x. And with that, we have to define x. So we'll say double, and it doesn't matter. Yes, it does. It's supposed to be in a floating type. So our argument, which this is our argument right here with this inside the parentheses. You should read or have read already that inside our argument should be a float. So that means it's a decimal, either a double or a float. In this case, we are using double. So we say double x and say equals a given number. Let's say negative 3.3. And let's say that. Okay. And let's run it. Compile and run it. Now we have 3.3 because we did not put either a comment in front of it so the compiler will not read it, or we could have put a new line so it can have separate lines. But we're going to put a comment so we only have that. We saved it, we compile it, run it. Oops. Before we do that, remember we always have to close out our running brand program before we can do anything. So saved it again, compiling and run it, and now it's 3.3. So the absolute value of negative 3.3 is 3.3. Now the next section is actually showing us that we can actually put more than one, or we can put a function, use a function inside a function. For instance, let's see, can we try this? Not sure it's gonna work. I've tried it at one expense, but it didn't. I see double x equals exp log 10.0, and there we go. Now, so we have x will equal to the exponent of log 10. So as you know, as in the order operation, we're going to do the log of 10 first, then we're going to do the exponent of that answer. So in order to get us an output, we have to get an output. We're going to see out x. So let's save this, or as I keep forgetting, let's close out that first. Now let's save it. Done. Let's run it. Let's see what output. We get 10. Now, since we got that, let's make sure we have all our answers correct. Let's see out log 10.0. Now the reason why I'm doing this is because we're trying to make sure that all our answers are correct inside, make sure we're doing all the operations correct, so we will know what's actually going on. So what I did here, let me put a little space, we declared x and we have the whole expression. So we're going to break it down first. We're going to say what is the log of 10, and then we're going to separate with a line and actually going to get this information. Now if I want to at first, I will have to put this answer somewhere, but we're just going to go one at a time. Alright, so let's see, let's run it, and log of 10 is 2.30259. So now we got this number 2.3059. So we take that. Let's this and see out the exponent of 2.30259, and we should get 10. And this answer and this answer should be the same thing. So let's save it. Okay, and let's compile and run it, and we do. So we broke it down to see how everything works, and we actually get the same thing. Sometimes you have to actually do it in that manner so we can see what's going on. And sometimes when you get to programming a lot better, you will actually know um, somewhat what the output should be. You can actually give it, and you'll see later on where you have user input, where we see these x's, this x right here, we can put in a different number, or matter of fact, in this number right here can be actually user defined to whatever number that you want to put in there. And with that being said, that you can be limitless, so you can test your answer. Just say, if you want to, if you had this in the future, you're writing your code, you would have this as user defined. You have a variable right here instead of a number, and then you have the user. You'll ask the user to put in the number, which could be yourself or it would be me, and we'll test. You can test it, and then I will test it with a known answer, and this answer is 10. You can answer it, and we'll know the output is 10. So what we'll do is, with our variable, you say what number would you like to put in. You put in 10.0, and your answer should be 10. And if it works, correct. If not, you'll have to go back and debug it and fix it and find out where your problem lies. Alright, we will have another tutorial section by itself only on the next uh, section and next half of the chapter, which is adding new functions. With this, we will go over how to add it, the information you need for it, and um, definition and its uses and things of that nature. So look forward to seeing my next video, which it should be right under this video.